All right, welcome back. Now, in the previous tutorial, we got to understand the concept behind overfitting and underfitting, right? We spent some time to understand what it is. Now, in this particular tutorial, we're going to see, we're going to have a practical hands-on as to how to prevent overfitting and then underfitting in our machine learning projects. Okay, so we will, by the end of the day, I expect you to get to know better techniques that you can use to deal with your in case you run into any overfitting or underfitting situation in your machine learning projects. Okay, so let's get started over here. I'm going to use two data sets over here, which is the weather data and also the fruit data set. Okay, so I've loaded this data at the resource session, so you can just download them and then we can work together. Okay, all right, so what I'm going to do over here is to import the various libraries that I'm going to use for this particular demonstration. So I'm going to import NumPy as np, then I'll import let me import pandas as pd, then I'm going to import matplotlib, okay, for our visualization, matplotlib, right, .pyplot as plt. All right, so far this is what I'm going to do, and I'm going to load this. We're going to first use the fruit data set. Okay, so I'm just copying the path over here. So I'm going to do pd.read underscore csv. Okay, and then I'm going to paste the path over there. Now I'm going to store this data as df, just simple df. Okay, so let me run this one then. Great. So let me just visualize some of them, right? So I'm going to do df.head. Okay, and then let me visualize the first 20 records. Okay, so now this is what we have, right? Let's see what we have over here. So we have fruit label, fruit name, mass, width, height, and then the color score. Okay, so each of the color of the fruit, they have given a score over here, and then the mass of the fruit, the width, and then the height of the fruit. Okay, and then each of the fruit name, right, they have given a label. For instance, apple is labeled as 1, mandarin is labeled as 2, apple 1, so whatever apple appears is going to be 1, orange is labeled as 3, and lemon as 4, right? There are other data types also, other fruits over there, right? So I'm going to do in order to see all the fruits, I'm going to select the fruit. Yeah, so I want the fruit name, right? Let's go down. I want the fruit name, then I'm going to do dot value, right, underscore counts, to see the different kinds of fruits that we have. Okay, now this is what we have. So we have apple, right, and then we have 19 of them. The count is 19. Or we have orange, count is 19, lemon, count is 16, mandarin, count is 5, mango, count is 2. Okay, now I'm going to do the same thing for the label as well to see the labels if it matches with the fruit names. Okay, so let me do that over here. And then instead of fruit name, I'm going to select fruit label. Okay, now you can see that it's the same. So 1 is for apple, which is 19, 3 is for orange, which is 19, 4 is for lemon, which is 16, and then 2 is for mandarin, which is 5, 5 is for mango, which is 2. Okay, the count is 2 over there. All right, so that is what we have. In this particular tutorial, I'm not going to do any data pre-processing and all those things. We've seen them over and over again. Our focus here is to see how to prevent overfitting and then underfitting. Okay, and this data set is quite clean, so I'm just gonna go ahead and divide the data into dependent and independent data set. Okay, so I'm going to do x equals df. Now what I'm going to do over here is that I'm going to, since the fruit name has been given label, ideally if they have not been given label, I should have given them label, but since they have already been given label, I'm just gonna use the fruit label instead of the fruit name. Okay, and I'm going to use the mass, the width, and then the height. All right, so based on the height, the width, and then the mass, I'm going to predict the fruit label. Okay, I'm not going to use the color score. It's not really going to contribute in helping me predict the fruit labels. Okay, so that is what I'm going to do. So for the x, I'm going to select I'm going to use iloc over here, and then I'm going to let me do this. I'm going to select all the records, right, and then I'm going to select from, let me see, 0 1. So 2, I'm going to start it from 2 3 4. Okay, so that is going to be 2 to 5. Okay, the interval 2 to 5, so that 4 will be inclusive. So that's what I'm going to do. Let me show you over here. I'm going to do from 2 all the way to 4, 2 to 5, and that is going to be 2 3 4. Okay, with those are I can specifically, I can specify the columns that I want to do, but this is also another way to do it. Okay, so df.ilog like that. Okay, and then for the y, right, for the y is going to be just the fruit label. So for that I can also do df.ilog, right? You can just avoid this ilog if you want, right? And then maybe use the color names straight away. So I'm going to select the one at the 0, which is the indexing, it starts from 0, right? So it's gonna be like this. Okay, it's gonna be something like this. It's gonna start from here 0. It's gonna be 0 1 2 3 4 5. Okay, so if I want from 1 to 4, right, in order for the 4 to come, I do 2 is to 5, so that it will be 2 3 and then 4. Okay, and then if I want only this one, I put 0 over there. That's the only thing I'm doing down there. Okay, that's what I'm doing over here. So let me run that. Great, always good. Now what I'm going to do next, let me actually print it for you to see before I move on to the next step. So I'm going to print the x, and then I'm going to print the y also for you to see. Okay, great. So in the x we have mass, width, and then height. Okay, that's what we want, right? Mass, we want to select the mass, the width, and then the height. And then for the y, we want it to be just the fruit label. Okay, so that's what you're seeing, right? The y value. So that's what you're seeing over here. All right, now let's see some of the techniques. Now we have loaded the data set. Now before we start doing these kind of solving the or preventing overfitting, let's see some of the techniques that we can use when it comes to preventing overfitting. Okay, so we have what is called cross validation, right? You can use what is called cross validation. I'm going to treat cross validation as a separate topic. Okay, so in this particular tutorial, I'm not going to do that part because I have a whole session on cross validation where we are going to do it into details. Okay, so when we get there, we will link it to this particular overfitting situation. All right, now what I'm going to do over here is the next step over here. You can also train with more data. Okay, so as in the real life, right? If the more you have experience, the more you can solve a lot of life situations. It's the same thing. If you train your model on more data, they get to learn better, and they get to make a better prediction in the future. Okay, it's just the same thing. And then remove some features. So it's also possible that sometimes it may happen that the model may fail to generalize simply because the model missed, right? It missed the patterns that should have been detected, right? And then the data was too complex for the same. And what I mean by that is that you might have some features that may not contribute to build the model, but yet they will be interfering with your model learning better. Okay, I'll demonstrate that to you as we progress, right? In this tutorial, I'm going to show you what I mean by that one. We also have what is called regularization, right, which I'm going to demonstrate that also to you, how to use these techniques to solve overfitting. Okay, so I'm going to start with training with more data. Okay, so now this is what we have, right? This is the data that we have loaded. Now I'm going to do the normal thing that we used to do, right? That is building our machine learning model on the data that we have. Okay, so I'm going to do that without doing any overfitting techniques over here. After that, then I'll show you how to solve the overfitting. Okay, so now let's see the normal things that we do. So normally what we do is divide our data into training and then testing. Okay, training and testing. So we use train test split. So I'm going to do from sklearn, which we have already used over and over again, right? sklearn.model underscore selection, right? Model underscore selection. I'm going to import train test split over here. Train underscore test underscore split. Okay, now I'm going to use the train test split to split the data that we have loaded. Okay, so I'm going to do train test split, and then inside that I'm going to put my x and then my y, right? And I'm going to specify my test size. So test underscore size Okay, test underscore size is equal to in this case I'm going to use 20%, right, for testing and then 80% for building. Okay, I'm going to use random underscore state, right, just set it to any value at all, right, just set it to 1. And then now when it's split, I want the x, the part of the x that I'm going to use to train to be in strain, and also the part of the x that I want to use for testing in test, right? And then the same thing for the y, right? So I'm going to have y train, and I'm going to have y underscore test as well. Okay, so that's what I'm going to do. So now let's run this one. Great. Now what I'm going to do next is to build a logistic regression to predict it. Remember what we have here, right? What you're going to predict is either we are going to predict 1 or 2 or 3 or 4 or 5. Okay, so it's a classification problem. Okay, so for that I'm going to use a classification algorithm, right, which in this case I'm going to use logistic regression. Okay, I'm going to use a logistic. Remember, we call it a logistic regression, but we use it for classification problem. Okay, so I'm going to do dot model selection, model underscore selection. Okay, and then I'm going to import, actually this is supposed to be linear model, so sklearn dot linear. Remember, logistic regression is present in linear model. Okay, and then I'm going to import logistic regression, capital R over there. Okay, that's what I'm going to do. Now once I do that, I'm going to initialize it to say LR, this is just a short form of logistic regression. Then I'm going to have this one over here. Okay, just need to initialize it. Then now I can use the LR to fit it. Okay, now I'm going to fit it on the test, right? So S train, right, bring the S train over here, and the Y train as well. Okay, that's what I'm going to do. So let me run this one so far. Great, so we've been able to create our logistic regression over here, right? So now I'm going to check how it is doing on both the training and then the testing data. Okay, so I'm going to do from sklearn, right, I'm going to import metrics, which inside metrics I can use score to score my my model. Okay, so over here what I'm going to do is that I'm going to use the model that we have built. Then I'm going to see how it is doing on the training data. That is the data that it has already learned from. Okay, so I'm going to bring that one here, and I'm going to print it out. So I'm going to do print, right, and I'm going to write over here training score. Okay, something like that, training score. Okay, and I'm going to do the same thing, but this time I'm going to check the score on the S test, right, the tested data. That is the data it has not seen before. Okay, so this time I'm going to call it test score, right, and instead of S train I'm going to use S test, and instead of Y train here I'm going to do Y test. Okay, one more bracket over here. Okay, so that's what I'm going to do. So I'm going to check how well it is doing on the training data. Remember, in overfitting, right, overfitting is where the model is going to do well on the data it has already learned from and do badly on the data it has not seen before. Okay, and then when it is underfitting, then it's not going to do well on both of these. Okay, so let's see which situation we have over here. Okay, now if you see what we have, if you see on the training, it's doing very well on the training, 72% or 73 approximately, but on the test you can see way worse, right, 46%. Now you can see the gap over here. It's doing very worse on the test. So in this situation we have run into underfitting over here. Okay, because in this case we have a model doing very well on the training data, but it's doing way worse on the testing data. Okay, which means that it just memorized the what do you call it? It just memorized the training data, right, and then give us a good score. But when we fed it with the testing data, which is the data it has not seen before, it's doing very, very worse. Okay, so in this case we have run into overfitting situation. Okay, we are now in overfitting situation. All right, now let's see how we can go around this one and then see how we can solve it. Okay, now if we check the count of the various fruits that we have, okay, I'm going to do fruit name, right? So if we check the count of the fruits that we have, right, let me do value count over here. You know what I want to express over here, and the value count. Okay, if we check now over here, you can see that we have 19 apple, we have 19 orange, 16 lemon, but if you see the mandarin and mango, they are only 5 and then 2. Okay, it means that it has ignored these 2 over here, since they are not that much over there. You just ignore them and then focus on these ones. Just memorize these ones, because after all, or maybe memorize these 2s that are dominating. Okay, because after all, they are the ones that are appearing most. So you're just going to say that, okay, it's likely at the end of the day, I'm going to predict these ones that are appearing. Just like in your college days, right, you have some past questions and then you see that the lecturer keep on repeating a particular kind of a question, right? So it's very likely that that question is at the end of the day is going to appear in your final exam as well. So you just memorize that. At least if nothing at all, you can score that one. Okay, it's just the same thing that the machine learning model is doing over here. It's just ignoring these ones that do not really appear. Okay, so if there's a particular topic that will do not really, your lecturer does not really set questions about, you are going to ignore that one, okay, and then learn the ones that he really set questions about. But who knows, at the end of the day, maybe he will bring questions like this, okay, and then you will fail miserably, just like our model has failed over here. Okay, so what we're going to do to solve this one is to do what is called upsampling. Okay, to do what is called upsampling, that is to make sure that the features that are having less data points are also having more data points in there. That is what earlier on I mentioned over here, right? To train with more data. Okay, so now we're going to make sure that we have more data for mandarin and mango as well, to match the size of this one, so that our model will not ignore them. Okay, that's what we're going to do right now. So we're going to use resampling technique, and in resampling we have upsampling and oversampling, right, and then downsampling and undersampling. Right, upsampling is where you make the features that are having small data points, right, match the ones that are having higher data points, and then downsampling is where you make the ones that are having higher data points to match with those that are having lower data points. Okay, so if you see this image over here, right, so if let's say this is the size of this is the size of apple, right? Apple is 19 and then mandarin is 5 or mango is 2. Okay, so if we take it this way, right, we're going to have, let's say this is apple, okay, and then apple here we have 19 over here, but mandarin is having only 5. Okay, now we want the size to be equal, so we want the size to be, say, 19 for mandarin as well, and then 19 for apple as well. Okay, we want the size to match, and that's what we're going to do over here, right? We are going to increase the size of the small one to match the size of the the bigger one, or the highest quantity over there. That's what we're going to do over here. So let's see how we do that. All right, now I have this small code over here which I want us to see. Okay, so I'm going to import a resample, right? Upsampling is a resample technique. Okay, so in sklearn we have what is called a resample. Okay, so from sklearn.utils you import a resample. Now what you're going to do is that you need to specify which data point that you want to resample, or which data point you want to increase the size. So I'm going to go into the fruit label, right, in the fruit label column, and I'm going to if I see the number 2, I'm going to select the number 2, that is the fruit label that is equivalent to the number 2. Okay, because if you go into our data set, let's go all the way up here, right, I'm choosing 2 because mandarin is labeled as 2. Okay, mandarin is labeled as 2, and I'm going to increase the size of that. Okay, that's why I'm choosing 2 over there, right? And so if you go all the way down here, right, that's what I'm going to do, right? Then I'm going to call it mandarin, right? Now over here, let me uncomment this one. Now I can specify which of the labels to that I want to match the size, right? So I want to match the size of margarine with apple, because apple is labeled as 1. Okay, so if you go all the way here, right, apple is labeled as 1, so I want margarine to match apple. Okay, so I want 2 to match with the quantity of 2 to match with the quantity of 1. All right, that's basically what I'm doing over here, right? And once you do that, you're going to use the resample that you imported over here, and then you specify which feature you want to resample, right? So in this case, it's going to be the margarine. And once you are going to resample, you're going to do sample with the replacement, meaning that if you go into the data set and you select, what we are going to do is that we're going to duplicate the 2, okay, as many times as possible, so that the number of 2s that we have will match the number of 1s that we have. Okay, so if we have let me actually do this one here. So if we have say this is our data set, okay, then we have 1, 2, 3, 4, 5, and so on and so forth. So we want to duplicate these 2. Okay, so we're going to create another data set which is going to contain the 1, the 3, the 4, the 5. Okay, but the 2 here we want to duplicate it. So if we pick the 2 and bring it here, right, we put it back, we make sure that the 2 is here again, and then we come and pick and then duplicate it again, duplicate it again, duplicate it again, until the size has matched the size of 1 which is in our data set. Okay, that's basically what we are doing. Right, so once we do that, right, that is replace equals true over there, right, and then we have n samples. Now the n samples you can put over here you can put that is the size that you want it to match. So you can put apple over here. Okay, you can put apple over here because I want it to match the size of apple. Okay, so you can do it this way, or over here, if you earlier on I had specified 19 minus 5, which means that apple is 19, then the margarine size is what? Is 5. So I want to add 14 more to it. Okay, that's why I'm doing this subtraction over here, so that the size, if I want it to match just the size of apple, right, if I want it to match just the size of apple, it means that I'm going to have 19 added to the 5 that we already have, the 5 margarines that we already have. Okay, what I'm trying to communicate is that already in our data set we have 5 margarines. Okay, we already have 5 margarines. Now we are going to say that we're going to duplicate this thing 19 times. Right, now if we do it 19 times, it's going to have 19 plus the original 5 that is there. Okay, that's why here I'm subtracting it from 5, so that we have 14 added to the original 19 which is there, but not 19 added to the 5 which is already there. Okay, to give me 24 instead of giving me 19. Okay, that's why over here I'm doing this one. Okay, otherwise you could have done maybe apple, right, apple and then minus 5. Okay, so that the size of apple, right, you can do length of apple, and length of apple is nothing but 19. Okay, length of apple minus 5 is going to give you the same thing. Okay, if I do it over here for you to see, right, let me print that one over here, right, and then I'm going to do print. So let me comment this one out and then run this one for you to see. Okay, now see that we have 14 over there, so this 14 is going to be added to the original 5 that we have over there to become 19. Okay, that is what I'm doing here. So let me just delete that one. Okay, let me get rid of that. So you can just do it like that, or you can just leave it to say 19 minus 5 like I did earlier on. Okay, and then random state, you can just set it to whatever that you want. All right, so let me run this one over here. Right, at the end of the day, I'm storing everything in this margarine underscore data app sampled, which is nothing but the margarine data that I have sampled. So now if I copy this one to show you what we have, let me run that. Okay, now you see what we have, right? Now we have fruit label, fruit name, mass, and blah blah blah. Now the 2 has been duplicated several times, as you can see over here, right? Now if you count them, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Okay, now we have 14. So we're going to add this 14 that we have duplicated, right, to the 5 that we have. Okay, so that it will become 19. Instead of having 19 over here and go and add it to the the 5 to become 24, right, instead of 19 that we want. Okay, so that's what we have. Now I'm going to do the same thing. Now we have done it for mandarin. We're going to do the same thing for mango. Okay, so let me copy the entire code over here and then come down here and paste it here. Okay, actually before I do that, let me even go and add this one. Okay, let me go and add this one to our data set. Okay, so let me come down here and then I'm going to add it to our data set. So I'm going to put both of them. So our original data set is called df, okay, and then the new one that we've created, where I mean the duplicated data points that we have created, right, is also called mandarin underscore data underscore upsampled. So that's what I'm going to put both of them in a list, and then I'm just gonna call them frames. Okay, I'm just gonna call them frame, right? That's fine for me. Now after I do that, I'm now going to do I'm going to use pandas to concat them. So I'm going to do pd.concat. Okay, so that I'll be able to put them together. So I'm going to put them together like this, and I'm going to say that axis equals 0. Okay, something like that, and that will become my new df. Okay, that will become my new df. So let me do that. That will become my new df. Then I'll print it the df for you to see. So let me run this and see what is happening here. Okay, let's see what has happened. Okay, now let me check the value count again, right? Let me go up here, all right, like we did over here. So let's check it again and see. Let me count here and then check the count. Okay, now you can see that mandarin is now 19, right? Earlier on, if you go up here and check the count of mandarin, right, it was 5. Okay, the count was 5. Now the count has become 19 because the 14 that we have here, this 14 has been added to the 5 that was already there. Now we have this 19. Okay, now it's possible that when you're running this thing, right, you're gonna run into an error, right? Especially if the index is like this. Okay, if the index is like this. Okay, so what you can do if you get into such an error, okay, what you can do is that you make sure you reset the index, right? Because this one, you see the index is messed up over here because it was just doing these things randomly and duplicating them like that for you. All right, so what you can do is to set the index of this one. So this is how you do it. You do this dot reset, right, reset underscore index, right, and then inside of this one you do drop equals true. Okay, drop equals true. You do it like that, and then that will become your new mandarin underscore that. Okay, you make sure that you reset the index. If I do this one and then I show you what we have in this again. Okay, now see, if you see the index over here, we have 0 all the way to 13. Okay, that's what you're supposed to do, right, instead of this one. Sometimes you can run into an error if the index is like that. Okay, all right, so basically that's what you need to do, right? And over here you see that I'm doing axis equals 0 because I want it to be concatenated column wise, right? Otherwise it will be concatenated row wise, and you see that after the color score it will start again with fruit label, right? That is, it is bringing the entire this thing, right? It's bringing the entire this one. It's going to carry this one, right, and then bring it over here and then paste them over here like that. Okay, that's what it's going to do. So you're going to also have another fruit label, fruit name, mass, weight, and this color score like that. But ideally that's not what I want. I want it to be added to each, fruit labels data over here should be added to the fruit label data over here. The fruit name should be added over here. The mass should be added like that, right? I don't want any other different rows over here. So that's why I'm doing axis equals 0 over here. Okay, so now I'm going to do the same thing. We've done it for mandarin. I'm going to do the same thing for mango. So now I'm going to copy the code, right, the same code over here, and then just change some things in there, right? Because now you can see that mango is still 2, right? But mandarin we have been able to upsample to 19, right? Now mango is 5, right? So if you check the df, or inside the df, if I do say df.head Let me see. Okay, here we will not really see. Let me print the first 50 and see. Okay, let me see if I'll find mango. Okay, I'm going to print, instead of head, I'm going to print tail, right? That's the last 50 records, and then see. Okay, now you can see mango, right? Mango is 5. Mango is labeled as 5. Okay, so that's, and it's only 2 of them. You can see over here, it's only 2 of them, right? That's why when we check it over, when we check it down here, we're having mango to be 2. Okay, so I'm going to do so now if I go into the fruit label, right, I'm going to select 5, which is mango, right? And I want the size to match apple. That is fine. This one I'm going to name it as mango. Okay, and then here -2, because in mango we only have 2 of them over there, right? And then this one I'll change it to mango as well. All right, and what else? Instead of Mandarin data app sample, this one I'm going to change it to mango data app sampled. Okay, that's the only thing that I have to change over here. All right, so now let's run this one and see. Great. Now if I check what is inside here, okay, now you can see that mango has been duplicated several times over here, right? It has been duplicated, and it's going to be duplicated with all the mass, the weight, and the score, right? Everything like that for you, right? Now this one looks very simple, but if you have about 10,000, 3,000 data points, right, this is very helpful technique to do. Okay, to duplicate your data set and increase the size of the data is actually a very helpful technique over here. Later on, when we are working on real world projects, you're going to appreciate this skill much. Very much, right? It's very few people know how to do this. Sometimes they spend a lot of time doing these things manually, going into opening the data in Excel and then start to duplicate them by themselves, manually. But you can use this thing over here to do it as easy as possible, right? Now we're going to do the same thing, right? So let me go up here and then all the way here. Let me change, let me see the index, right? I'm going to change the index over here so that it will not interfere when I'm concatenating. Okay, so let me see how I did this one. I'm just gonna copy it, and then I'm going to come down here, right? And instead of Mandarin, I'm going to do mango. Okay, that's it. Now let me run it. Good. And then let me show you what we have now. Great. So instead of those 60 that we're having over here, right, we have from 0 all the way to 16. Okay, that's what we have. So let me now come back. Let me go into, I'm going to concatenate it, so I'm just going to copy that code that we used to do the concatenation, which is this one, right? Let me go all the way down, and then I'll paste it over here. Now instead of Mandarin, it's gonna be mango, right? Let's run and see. Great. Now let's now check it again and see the samples, right? So I'm just gonna copy this code, come back down here, and I'm gonna run this one to see. Great. Now you can see that mango is now also 19. Right now we have been able to upsample. If you want, you can also do it for lemon, but lemon is having enough data already, so there's no need doing it. Okay, now you can see how we've been able to increase the data, right? So now we're going to build the same logistic regression that we built earlier on, okay, which we were having overfitting, right? So earlier on we built that particular logistic regression, and then we saw that on the training we're doing better than on the testing, and then we tried to see that we are going to solve it. Okay, on the training we're having 72, on the testing we're having 46, which was very bad. The model is overfitting, like, seriously. So we've sampled these data points, right, to increase the data points that we have. So we're going to build the same logistic regression again. So let me go and then and now I'm going to divide the data set again. Remember, we have created a new data set which contains new x and then new y. So I need to now split the data again. I mean, we have a new df which contains equal number of features over there, a count of features over there. So I'm going to split the data again. So let me bring this one here. All right, and then I'm going to create my x and y again. Great. So I'm just going to follow the same steps that we used when we're building the earlier logistic regression. So I'm going to get this one over here, right, to split the data into training and then testing. All right, so let's go all the way down and down here. All right, so now let's split the data. Great. So what is the next step over there? Let's go and see. After splitting, we now have this logistic regression being initialized and fit on the data. So we're going to do the same thing over there, right? So let's go all the way down, all the way here. Okay, so I'm just going to run it again. Great. So we've created the logistic regression. Now let's go all the way up, and now it's time to check if we're able to solve this overfitting issue that we run into earlier on, right? So this is the step that we're gonna do, right? That is checking if the training data is still doing way better than the testing data. Ideally, the training data is going to do better than the testing data, but the gap shouldn't be as much as we saw, right? Like 72 and 46. So let's see if now we've been able to bring the test score closer to the training score. Okay, let's see what happens. Great. Now you can see on the training we have 76, but on the test now we are even doing better, 78, right? Instead of earlier on we're having 76, 42, right? If we see what we were having, what we did earlier on, right, where we're having overfitting, 72, 46. Now we see that after we improved the data, or we increased the data, we are doing way better, right? We're doing way better. Okay, we're doing way better. That is 76 and 78. That is great, absolute great improvement over there. Okay, so now you appreciate how it's going to help you if you solve this kind of overfitting issue. Okay, and this is one of the techniques to use to solve overfitting issue, that is increasing the data. Okay, increasing the data. All right, now that is one of the techniques, right? I've shown you one of the techniques. If I go all the way up here and see the techniques that we have, right, we also have another technique that we can use in solving this. Okay, so I've shown you how to add more data, right? And that's what you're going to do in the industry when you run into such kind of situations. The next one is to remove features and also regularization, right? So let me show you this one, right?